good morning, afternoon, evening, whenever you're watching this. Today we're doing 7-3, sum and difference identities. 3 more lessons left. Woohoo! Okay, we are on page 438 and 439 area. I'm not going to go through the proofs with you guys, so if you would like to see how they got to these equations, please feel free to take a look at those pages. Okay, but when we start talking about 7 difference identities, we're kind of talking about this. So what if we have some angle, and we want to know something about this angle, but all we know about it are the 2 angles that make, but we need to use the angles that make it up to find the angle, okay? So that's kind of what we're talking about with our sum and our difference identities. So we want to get to angles that are common angles that we know, okay? All right, so we'll talk about the identities, how to use them, do some practice problems. So sum and difference identity for cosine. A and alpha and beta represent measures of 2 angles. So the cosine of alpha plus beta equals the cosine of alpha times the cosine of beta minus the sine of alpha, sine of beta. Or cosine of alpha minus beta equals cosine alpha, cosine beta plus sine alpha, sine beta. Okay. What do you notice about the signs? Well, in cosine, when you're adding the 2 angles, it is a subtraction between them. When you're subtracting the 2 angles, it is an addition between them. Okay. Look at my next note. So notice how they relate. All right, example. Show by producing a counterexample that cosine of x plus y is not equal to the cosine of x plus the cosine of y. This is another chapter that having your unit circle out will be really helpful because we're using common angles that we know. Okay, so we're going to pick some angles that we know. So on this one, we're going to say that x equals pi over 3 and y equals pi over 6. Why did I choose those? Those are angles that we know and we've used a lot. Okay. All right, so what we're going to do is we're going to pretty much plug these in to each piece to show that they're not equal. All right, so I'm going to start with cosine of pi over 3 plus pi over 6. And I'm going to say that that does not equal the cosine of pi over 3 plus the cosine of pi over 6. So our goal, we want to make sure and prove those are not true. Okay, so the cosine of pi over 3 plus the cosine of pi over 6 is going to be equal to pi over 2. So if we think about this, the cosine of pi over 3 would be 2 pi over 6 plus pi over 6 equals 3 pi over 6 or pi over 2. Okay. So the cosine of pi over 2 over here. If we take a look at the cosine of pi over 2, that would be a 90-degree angle. Okay. The cosine at that point is 0. Okay. We're proving that they're not equal. Okay, you could put a question mark here to show that we're working to prove that. So the cosine of pi over 3, so you can check your unit circle, go over to the cosine of pi over 3, and that's going to be 1/2 plus the cosine of pi over 6. It's going to be root 3 over 2. Okay, add those together. We're going to have 1 plus root 3 over 2. Is 0 equal to that? Nope. So we can check it off that we proved it right here. This shows it. So not equal. Those two show y. All right, so the next question says, show that the sum identity for cosine is true for the values used in part A. All right, so what it wants us to do is it wants us to take the cosine identity, this right here, and using this, prove that it's true. So pretty much just checking it. So we're going to say, okay, the cosine of x plus y equals, I remember we're doing the top one, so the cos of x cos y minus sine x sine y. Why am I saying cosine? Goodness gracious, it's late. All right, so now we're going to use that x equals pi over 3, y equals pi over 6. And we're going to plug them in. So we're going to say cosine of pi over 3 plus pi over 6 equals this. So does that equal? Well, not that one. We know that one's equal. But does this one equal right here? That's what we're going to check. So cosine of pi over 3, cosine pi over 6, minus sine pi over 3, sine pi over 6. Okay, sweet. We have some of this above. So up above, we found out that this is equal to 0. Okay, now we got to work on this side. So cosine of pi over 3 up here was 1/2. Cosine of pi over 6 is root 3 over 2. Okay. Sine of pi over 3 is root 3 over 2. Okay, unit circle again. Sine of pi over 6 is 1/2. So we have square root of 3 over 4 minus the square root of 3 over 4. So 0 equals 0. Check. So that proves that the sum identity works. Okay. We could also do the difference identity if we wanted to, but believe me, it works. All right. The sum and difference identity help to find the value of an angle using common known angles. All right, so using your unit circle. Use the sum or difference identity for cosine to find the exact value of cosine 735. Okay, well, first thing we're going to need to do is find out what in the world 735 is. So I'm going to go 735 minus 360, okay, minus 360. So we know that it is 2 360s plus 15, okay? So really we're looking at sine of 15 because we're going to be looking at angle of 15 because this is all the same, right? So we could say degrees, 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 all right? So really, cosine of 735 is going to be the same as cosine of 15 degrees because of the periodicness of our cosine functions, our trig functions, all right? So the next question is how can we write the cosine of 15 degrees in another way using a sum or difference? Well, we know the cosine of 45 minus 30, okay? So that could help us find 15. Awesome. Now we need to use this and plug it into our difference formula, okay? So I'll write over here, the difference formula is cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. Okay, so we're going to do cosine of 45, cosine of 30, plus sine of 45, sine of 30. Now we're going to use our unit for circle to find out what the cosine of 45 is. And we'll find out that that is root 2 over 2 times the cosine of 30, which is root 3 over 2. The sine of 45, root 2 over 2. The sine of 30, 1/2. Okay, so we're going to have root 6 over 4 plus root 2 over 4. So root 6 plus root 2 over 4. We can't add the roots together. So in the end, the cosine of 735, which was our original angle, is this. That's what the point of these equations are. All right, let's go on to the next. Okay. So we're going to do this now for sine, and then we'll also do it for tangent. Okay. So for the sine proofs, you can see page 439, but this is the sum and difference identities for sine. Sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Okay, you'll notice the signs are the same on sine. Sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. These are great things to have written down on a formula sheet. Hint, hint. Okay, all right. Find the value of sine x minus y if x and y are constricted into these areas. Okay. All right, so in order to find, to use the difference formula, we need the sine and the cosine for these. You'll notice that right here we have the sine of x and the sine of y. So we need to then find out what the cosine of x and the cosine of y is going to be. Okay. So what it is saying we can do is we can use the Pythagorean identity of sine squared of alpha plus cosine squared of alpha equals 1. Okay. Which then is the same as cosine squared of alpha equals 1 minus sine squared of alpha. Okay, because we're trying to find our cosines. Okay, then it is also equal to, so cosine of alpha is equal to the square root of 1 minus sine squared alpha. Because we square rooted, we have to use plus or minus. That's when we're going to have to okay, because it tells us that we are in quadrant 1 because we're constricted right here to quad 1. We know we're going to take the positive of this when we plug them in. Okay, so we're going to do cosine of x equals the positive, because we're in the first quadrant, 1 minus sine, okay, sorry, we don't actually need that. Okay, we know that sine is 941, so then we need to just square that. Okay, that's how we find cos of x. Cosine of x. Okay, and then if we're going to find okay, let's solve for that before I go on. Okay, so cosine of x is going to equal 1 minus 81 over 1681. Okay. And then we can say that cos of x equals, this is the same as saying 1681 over 1681 minus 81 over 1681. So cosine of x equals the square root of 1600 over 1681, which equals, the square root of 1600 is going to be 40, and then the bottom we knew was 41. Right? So that's what the cosine of x is. Now we need the cosine of y. We need to do the same thing. 1 minus 725 squared (1 minus 49 over 625. Okay. 625 over 625 minus 49 over 625. In your book, it just like simplifies these super quick for you, but I just wanted to see, I wanted you to see why. Okay, the square root of 576 is 24. The square root of that was 25, so that's the cosine of y. All right, so now it wants us to plug it into this sine subtraction formula. All right, so what we're going to do is, realistically, it wants sine of x minus y is going to equal sine of that, sine of x, so we already know that's 9 over 41, times cosine of y, which we found was 24 over 25. They're the same sign. Now the cosine of x was 40 over 41, times the sine of y, which is 7 over 25. Okay. So then we just need to find out what that equals. So the bottoms are both going to be 1025. Yay. So 216, 280, so 216 minus 280, negative 64 over 1025. Or approximately negative 0.0624. Yep, it's a process. Nice thing, formulas right there for us. Okay? I didn't even use my calculator that much, just to do some simple multiplication I didn't want to do in my head. Okay. All right. The example for this is on the top of 437. Okay. So what it's telling us is, I'm going to find it for you. It says, have you ever had trouble turning into your favorite radio station? Does the picture on your TV sometimes appear blurry? Sometimes these problems are caused by interference. Interference can result when two waves pass through the same space at the same time. There are two kinds of interference. One is constructive interference, which occurs when the amplitude of the sum of the waves is greater than the amplitude of the two component waves, or destructive interference, which occurs when the amplitude of the sum is less than the amplitude of the component. Which type of interference results when a signal modeled by this equation is combined with a signal modeled with that equation? Okay. So here's our questions right here. What type of interference results when the signal models by the equations, this and this, are combined? Okay. So what we're doing is we are going to add the two sine functions together, and then we are going to simplify them. Okay. So I have 20 sine 3t plus 225 plus 20 sine of 3t plus 45. I probably just wrote those opposite of the book, so now I'm going to confuse this as we go. Okay. So what we're going to do is we are going to use two sine formulas, a sine formula for this and a sine formula for this, before we can reduce and come up with one answer. Okay? It's going to get a little crazy and messy. Have fun with it. Okay? The example is on page 440 in the book also, if you want to look at it. So what we're going to do is we're going to take this one and we're going to use the addition of sine from above. Okay? So 20 is going to go out in front. And the first thing is we're going to have sine of the first thing, cosine of the second thing, plus cosine of the first thing, sine of the second thing. All right, and then we're going to add that to sine of the first thing, cosine of the second, cosine of the first, sine of the second. All right. So now we're going to do some simplifying. Okay. So I'm going to start with 20. I don't know what sine of 3t is. But I know that cosine of 225, if I use my unit circle, I know that that is negative root 2 over 2. Right? I don't know what cosine of 3t is, but I do know that the sine of 225 is going to be negative root 2 over 2. All right, so we're going to do that over here too. I don't know the sine of 3t, but I know that the cosine of 3t is going to be, the cosine of 45 is going to be the square root of 2 over 2. And I don't know the cosine of 35 there, of 3t, but I know the sine of that is going to be the square root of 2 over 2. Right, so just did the simplifying that we could do. Okay, so now what I'm going to do is I'm going to distribute the pieces that I can and solve. All right, so I'm going to give the 20 to this piece right here. If I do, I have a 2 on the bottom and here, so I'm going to have negative 10 root 2, because I did 20 in this piece, sine of 3t, because I can't reduce that. Now I'm going to put the 20 times this, so 20 and that, so I'm going to have a negative 10 root 2 cosine of 3t. Okay, now I'm going to distribute my 20 to here, the 2, so I have 10 root 2 sine of 3t plus 10 root 2 cosine 3t. All right, so let's see. I have a 10 root 2 cosine 3t and another one here. So these lovelies are going to cancel each other out. And I have a 10 root 2 sine of 3t and the negative there. So those lovelies cancel out. And in the end, we get an answer of 0. Okay. So if we go back to the directions that it told us, it told us if the amplitude of the sum is less than the amplitude of the components, well, our amplitude, it says there's two options. A constructive interference, when the amplitude of the sums is greater than the amplitude of the components. So the amplitude of our components were 20, because remember that's an amplitude out in front. And our answer was 0. So is it greater or less than this? It's less, which if we look, that's a destructive. So this is called destructive interference in this situation. Because actually what happens is our two waves are actually canceling each other out. Okay, kind of interesting. All right, last thing. Okay. You can use the sum and difference for cosine and sine to find the sum and difference for tangent. So here it is. Okay. You can also, let's see. Nope, they didn't actually derive that for you. You're supposedly going to later, but I don't think I assigned it to you. So there's the equation. So we're going to try it out and use it. Okay. So it says, use a sum and difference identity to find the exact value for tan of 285. Well, we need to figure out 2 degrees that we know to make 285. So 2 angles that we know on our unit circle would be 40 plus 45. So 2 sums of common angles we have on our unit circle. Once again, unit circle would be handy. Oh, and I should have a tan in front. Okay. All right, so now we're going to plug these into our equation. Okay. So it's going to be, because this is a plus, we're using the top. So it's a plus on the top and a minus on the bottom. Okay. So I'm going to say tan of 240 plus tan of 45 over 1 minus tan of 240 tan of 45. Okay, get out that lovely unit circle. Okay, so tan of 240, if you take a look at it, it is root 3. Tan of 45 is 1. Tangent of 240 was root 3 times 1. So this is 1 plus the square root of 3 and 1 minus the square root of 3. We don't want to have square roots in the bottom, so we're going to multiply by the reciprocal. Of this. So that's going to end up with the goal is that this just am I doing? Okay, so let's do it because it's, okay, so I'm going to end up with 1 plus 2 root 3s plus 3 over 1 minus root 3 plus root 3 minus 3. Right? So I'm going to equal with, I'm going to have 4 plus 2 root 3 over, let's see, these cancel. 1 minus 3 is negative 2. So I'm going to have 2 plus the square root of 3 over negative 1, which means I need to make each piece negative. So negative 2 minus square root of 3. And that's my answer. Okay. All right, last one. You can use the sum and difference identity to verify other identities. Okay. So verify that cosecant of this minus secant of A is an identity. So let's transform this more complicated side to try and equal negative secant of A. Okay, so we'll draw that line down. Okay. What could we change this sign to? Let's change it to a sign. 1 over sine of 3 pi over 2 plus A equals negative secant of A. All right. We have a sign with a plus, so let's use our sign identity from the last page. So what we can say is sine of 3 pi over 2 cosine of A plus cosine of 3 pi over 2 sine of A equals negative secant of A. Sweet. We know what sine of 3 pi over 2 is. Using our unit circle, it's going to be negative 1 cosine of A. Okay. Cosine of pi over 2 is 0. So that means that this is going to simplify and go away. Okay, so now I have 1 over negative cosine of A. Okay. 1 over cosine of A is the same as secant, so we'll have negative secant of A equals negative secant of A. Check. Okay, it works. All right. Homework is page 442, number 15 to 31 odd, 37, and 39. Have fun.